So after you have put your name at the top here, after you have read the question, to make a start, you'll notice that we've got these two different riverboats that we're comparing, the Kinloch one and the Turangi one. So what I'm going to do is I'm just going to call my first Kinloch. Okay, so the wheel of the riverboat, so here's the wheel. It has a diameter of 5 meters. So what diameter is it's not the radius, not halfway, but the whole way across the circle. So from the probe all the way to the top, it's 5 meters. Now at the wheel's highest point, so along here, it's 3.3 meters above the water level. Now we're assuming that the water level is at 0 meters. So what that means is that we have the max given to us. So you have the max, and that is 3.3. Now to find out the minimum, what we can do is we can go our maximum, which is 3.3, and we want to get all the way down to the bottom. So what we can do is we minus the diameter from the maximum. So if we go 3.3 minus 5, we get a minimum of negative 1.7. So that means it's 1.7 meters below the water. Okay, so we have our maximum and our minimum. Alright, now the next thing that we can do is we can work out our amplitude. So our amplitude, that is our max minus our min, and then we divide it by 2. So that is 3.3 minus negative 1.7, and then we divide that by 2. And in this case, it is 5 over 2, or 2.5. That's our amplitude. Okay, our what can we do next? Our vertical shift. So the formula for that is max plus min divided by 2. So that's 3.3 plus negative 1.7 divided by 2. So that's the same as 3.3 minus 1.7 is 1.6, divide that by 2, so we have 0.8. That's our vertical shift. Alright, now we have a period that's given to us. So our period is 8 seconds. To get our frequency, we need to go 8 divided by, what's the frequency, as well as period divided by 2 pi. So our period divided by 2 pi, which in this case is 8 divided by 2 pi, which can be simplified to sorry, not period divided by 2 pi, it is 2 pi divided by period. So in this case, it would be 2 pi divided by 8, which is equal to pi on 4. So that is our frequency. Alright, and finally, we want to find out our horizontal shift. Now that is negative time to max, and that's for a cos curve, so we're going to use a cos curve here. So if it's going to take 8 seconds to get all the way around, that means it's going to take 4 seconds to get to the max. So horizontal shift here is negative 4. So we have our equation. We can look at it like this. So we have our probe is equal to, actually I'll write out the general formula first. So we got y is equal to a cos b t x minus c plus d. In this case, I'm going to look at it as the height of the function time. So you've got a cos b, and then instead of x, we've got t plus c plus d. So instead of our a, we have our amplitude of 2.5. Instead of our b, we have our period of pi on 4. Instead of our c, we have -4. And then our vertical shift is plus 0.8. Cool. So that is our Kinloch graph. All right, now what we could do is we could put this into Desmos. So I'm going to open up Desmos over here. Okay, and so we go y is equal to 2.5 pi over 4, and then x minus 4 plus 0.8. Oh, and I forgot my cos. Alright, so if we have a look at this, we start at our minimum of -1.7, which is what we wanted. We've got our maximum of 3.3, so there's a difference of 5, and then it takes 8 seconds to complete a full turn. So we're happy that that is our curve. Alright, now what we can do is we can do our next boat, which is the Turangi boat. Okay, so the max for this boat is 4.2. So we got a max of 4.2. Now our min, so we can go 4.2 minus our diameter of 6. So it's going to be -1.8. Now amplitude is our max minus our min divided by 2. So it's 4.2 minus our min divided by 2. So that's going to be 6 divided by 2, so that's going to be 3. And you'll also notice the amplitude is half of the diameter. So for both of these, amplitude is half of the diameter. That's because the diameter is the full length from the top to the bottom, so amplitude is half of that. Okay, next thing we've got is our vertical shift, which is 4.2 plus -1.8, which is 4.2 take away 1.8. Divided by 2, and that is going to be 1.2. We have our period of 12, and so we have our frequency of 2 pi divided by 12, which is equal to pi on 6. And finally, horizontal shift is negative time to the max. So in this case, it's going to be -6. So we have our curve is 3 cos pi on 6 t minus 6 and then plus a vertical shift of 1.2. Right, now if we plug that in here, we've got y equals 3 cos pi on 6, x take away 6, that's 1.2. Okay, so we have our maximum of 4.2 and our minimum of -1.8, and then we can see that our period is 12. Okay, so we have both of our equations. Alright, now what we're trying to look at is when are both probes underwater. So I'm going to say down here, both probes are underwater. So both probes are underwater between 0 seconds and 1.585 seconds. So I'm going to put T, it's at 1.585. And then we have both probes are also underwater between 22.414 and 25.585. So 415 and 25.585. And if we keep going, they're both underwater again between, what's it now about? 46.415 and 49.485. So 46.415 and 49.585. I'm just going to do one more. So between 70.415 and 73.585. So I'll show you how I got that. So I did these last 2 points here. Alright. I'm also going to take a screenshot of this as well. So take a screenshot, showing that. Alright. So both probes are underwater during these time intervals in seconds. Okay, so something like that would be getting up to our relational thinking or our mirror. But what we want to do next is we want to get up to our next stage. We want to get up to excellence. Okay, now what we can see is between 22 and 46 and 70 and 25 and 49 and 73, it looks like there's a bit of a pattern. So between 22 between 4 and 5, so if we go 46.415 minus 22.415, you see that is equal to 24. And if we go 49.585 minus 25.585, we also see this is equal to 24. We also see that between 70 and 46 is 24, and between 73 and 49 is 24. So what's happening is we've got this pattern of 24. So what we can say is between 46.415, essentially say general equation. So between 22.415 plus, we're going to say 24 in seconds and then 25 plus 24 in seconds. So general equation is that. So I can say 0. So also between 0 seconds, 1.585 seconds. So these are the times that the probe is underwater. And then we're going to say, we need to make sure we say for any positive whole number n. So the probes both underwater every 24 seconds from the time interval above. Something like that you could say to finish your question. And that would be this question solved.